You are probably already familiar with angles measured in degrees, but I want to show you something a little different and also remind you of some things you already know. First of all, we are going to talk about oriented angles, angles that are placed on a grid in a certain position. We call this putting an angle in standard position. In standard position, one side of the angle is on the what we would consider the positive x-axis. That would be considered 0 degrees. And then we move counterclockwise up this direction until we get to what's called the terminal side of the angle. So the initial side of the angle is on 0 degrees. This is the terminal side of the angle. So we call this a 40-degree angle. This is an acute angle, an angle that's between 0 and 90 degrees. Hopefully you recall that a 90-degree angle is called a right angle, and it's denoted with a little square in the corner. Then if we move past 90 degrees, we have an obtuse angle. This is still an angle in standard position measured from 0 to 130 degrees. Then if we keep moving farther down, we have a 180-degree angle, also known as a straight angle. Now there aren't any names for angles bigger than 180 degrees that I know of, but we can still have angles that are bigger than 180 degrees. Obviously they won't fit into a triangle, but we do have, this is a 234-degree angle, straight down would be 270, and then we get back to 360 in which or 0. So 360 or 0 is the same angle. Now, this protractor won't show it, but we can also have angles bigger than 360 degrees. So, for example, this would be if I started at 0, and let me take a pen to show you this, go all the way around and then back to here again, this would actually be a 390-degree angle. Now, we could also take this angle and move it backwards. So this says 310, but if I went backwards this direction, I could call this a negative 50-degree angle. So we have positive angles going counterclockwise and negative angles going clockwise. Let me draw this one in sort of so we can sort of see that one. We have straight angles, right angles, acute, obtuse, positive, and negative. These are angles in standard position. Now I'm going to take you to a little video clip to introduce the next type of angle measure that we have. This is a little applet you can find online, although some people will have trouble opening this on their devices, so I thought I'd include some of this in my video.
Two methods are typically used to measure angles. They involve degrees and radians. The Babylonians chose to divide a circle into 360 sections. Select next to learn why they picked the number 300. One theory was that 360 was chosen because the Babylonians believed it took 360 days for the sun to pass around the earth. Radian measure is based not on a number chosen by man, but on the basic components of a circle. A radian is the measure of the central angle subtended by an arc equal in length to the radius of a circle.
That's an important definition, and we're going to talk a little bit more about that because the word subtended is something you may not be familiar with. Now I want you to pay particular attention to the animation on the next couple of pages.
A central angle has its vertex located at the center of a circle. This is subtended by an arc equal to the length of the radius. The green sector represents an angular measure of 1 radian.
For an angle to subtend an arc, or an arc to subtend an angle, I've seen it written both ways. It just means that when you draw the angle from the central angle of the circle here, the edges of the angle, or the two rays that form the angle, cut off a section of a circle, and this is the arc subtended by that angle. So when we say that we have a 1 radian angle, it is an arc that subtends or cuts off a section of the circumference of the circle that's equal to 1 radius length. I'm going to replay this so you can see this happening again.
This is subtended by an arc equal to the length of the radius. The green sector represents an angular measure of 1 radian. Let's view an illustration of 2 radians.
Okay, so you notice then that a 2 radian angle, which would be an angle from here to here, notice it's in standard position, cuts off an arc that's equal to 2 radius lengths of the circle.
Let's view an illustration of 2 radians.
Now notice in my drawing here I have that definition of a radian angle illustrated. A radian is an angle that subtends or cuts an arc length equal to in length to 1 radius of the circle, and it is a central angle. Its vertex is on the center of the circle. Now if I continue to draw radius lengths around the edge of the circle, around the circumference of the circle, there would be 2 radians, 3 radians, so circle would go all the way over to here, or the angle measure would go all the way over to here, 4 radians, 5 radians, 6 radians. You can see that there are more than 6 radians in a circle, but not quite 7, actually not nearly 7, a little bit more than 6. So what exactly if we wanted to find exactly how many radians in the circle, how could we figure out this amount? And the answer comes from geometry. Let's say that the radius is equal to 1. Well, we know from geometry that circumference is equal to 2 pi times the radius. Now, if the radius is 1, then the circumference would be 2 pi. Now let's think about pi. You know that pi is 3.14. Well, notice halfway around the circle looks like that would be reasonable. That would be pi. And all the way around the circle would be 2 pi. 3.14 times 2 is about 6.28. And it turns out, and that looks about right, that that's about 6 1/4 radians. It turns out that all the way around the circle is 2 pi radians. Now to see how radians and degrees correspond with one another, let's take a look at our circle marked out in radians with a protractor on it. So if we look at 1 radian angle is about 57 degrees. It's actually 57.3 degrees. I can do that by taking 180 degrees divided by pi. It's the ratio. We'll talk more about converting between radians and degrees, but just to give you a feel. 2 radians then is a little over 114 degrees, 3 radians about 173, 4 radians about 200, and I think it's about 229, 5 radians about 286, and 6 radians about 344, I think, degrees. And this gives you a little feel. Then if you know that 1 radian is about 57 degrees, you can get more of a feel for how many radians are in one complete rotation of a circle.